we're diving into a paper that explores a fascinating approach to aligning language models with human intent. The paper, Training Language Models to Follow Instructions with Human Feedback, proposes a method for fine-tuning large language models using human feedback. What are the key challenges that this paper addresses?
The paper tackles the issue of misalignment in large language models. These models are often trained on massive data sets of text, but they don't inherently understand the nuances of human intent. This can lead to outputs that are untruthful, biased, or simply unhelpful. The paper aims to address this by training models to follow instructions and align with human preferences.
So how does this paper propose to align language models with human intent?
The paper utilizes a technique called reinforcement learning from human feedback, RLHF. This involves collecting human demonstrations of desired behavior and using them to train a reward model. The reward model predicts which outputs humans would prefer, and the language model is then fine-tuned to maximize this reward.
Can you elaborate on the process of collecting human feedback?
The researchers collected two types of human feedback: demonstrations and rankings. Demonstrations are examples of desired outputs for specific prompts, while rankings involve humans comparing different outputs for the same prompt and indicating their preference.
How does the paper use this feedback to train the reward model?
The reward model is trained on the collected rankings. It learns to predict which output a human would prefer given a prompt and a set of candidate outputs. This model acts as a reward function for the language model during fine-tuning.
And how is the language model fine-tuned using this reward model?
The language model is fine-tuned using a reinforcement learning algorithm called proximal policy optimization, PPO. The reward model provides the reward signal, and the PPO algorithm updates the language model's parameters to maximize the expected reward.
This sounds like a complex process. What are the key benefits of this approach?
The paper demonstrates that this approach significantly improves the performance of language models on a wide range of tasks. The fine-tuned models, called InstructGPT, outperform the original GPT-3 models in terms of human preference, truthfulness, and reduced toxicity.
That's impressive. Can you give us some specific examples of how InstructGPT models perform better than GPT-3?
In human evaluations, InstructGPT models with significantly fewer parameters were preferred over the larger GPT-3 models. They also showed improvements in truthfulness, as measured by the Truthful QA benchmark, and generated less toxic outputs when instructed to be respectful.
It's interesting that InstructGPT models can outperform larger models. Does this mean that model size is not the only factor determining performance?
That's right. The paper highlights the importance of alignment with human intent. While larger models may have greater potential, they need to be trained to understand and follow human instructions effectively.
The paper mentions an alignment tax. What does that refer to?
The alignment tax refers to the potential performance degradation on certain tasks when a model is fine-tuned for alignment. The paper found that InstructGPT models showed some performance regressions on public NLP datasets, but these regressions were mitigated by incorporating pre-training data into the RLHF fine-tuning process.
So the paper suggests that we can improve alignment without sacrificing performance on other tasks. What are the implications of this for future research?
This finding is significant because it suggests that alignment techniques can be developed without compromising the capabilities of large language models. It opens up possibilities for creating models that are both powerful and aligned with human values.
The paper also explores the generalization capabilities of InstructGPT models. What did they find?
The researchers found that InstructGPT models showed promising generalization to instructions outside of the RLHF fine-tuning distribution. For example, they were able to follow instructions in different languages and perform tasks related to code, even though these tasks were rarely encountered during training.
This is encouraging. It suggests that alignment techniques can help models generalize to new tasks. What are the limitations of this research?
The paper acknowledges that InstructGPT models are not yet fully aligned or safe. They can still generate harmful outputs, make up facts, and fail to follow instructions in certain cases. Further research is needed to address these limitations and ensure that these models are used responsibly.
This was a fascinating discussion on the technical aspects of aligning language models with human feedback. Thank you for your insights.